Yeah, hi everybody. I'm Tarek from BioDigital. I'm going to talk to you a little bit. This group actually ended up being a little more technical than I thought it was going to be. I prepared a bit of a higher level talk. So I'm going to be talking about just a bit, like we're a company, we base a lot of our business model on WebGL, and talk to you a bit of like the opportunities and challenges that come with using that technology. Just to get a sense, like how many, is everybody familiar with WebGL? Everybody know? Who doesn't know, really? I see someone who does. Okay, so I'm going to talk a little bit about what it does. So first, yeah, I'll talk a little bit about the company. So BioDigital, our goal is to use interactive 3D on the web, so using WebGL, to make anatomical content engaging for our users and the users of our clients. A key thing is we want to move beyond the anatomy atlas. Like I'm sure everybody's seen these books where it's like, you know, pages of, you know, parts of the body and like the names and all that stuff. So we want to use this technology to kind of take things further, to bring the content to life, use animation, use the interactivity to really let people get into the data, and then of course make it accessible to everyone through the web. Oh, this guy didn't load quite. Liked. There we go. So this is the kind of stuff we do. So this is an animation of running mechanics. And you can kind of like go through, look at different parts of the model, and interact with this guy. So that's essentially it. Like our platform is, so we have a big 3D content library, like all these models and animations that we put together. 5,000 anatomy objects, a bunch of health conditions, so like variations on those objects show certain diseases or other just special cases of that of the anatomy. Our rendering engine is built on Scene.js, which is a JavaScript library for WebGL. And then we have our users go in and sort of annotate, where they can like point out certain parts of the anatomy, create custom views, and share them with each other. And then we recently released our API, which is basically it's to allow people to embed our content into their websites and create custom interactions around them. So some of our big clients, medical device manufacturers and pharmaceuticals, they love this stuff because they can put something on their website that sort of shows how, you know, shows doctors how to use the devices they've come up with, or show patients how a drug will affect their body. And then of course there's the educational use cases. Med students form a big part of our user base. So WebGL, for those who don't know, it's basically like, it's a JavaScript API, native in the browser, that allows access to the GPU. So basically what that means is that you can do high performance 3D graphics, interactive on the web. Like you can stick these 3D scenes in a web page. Why do we like WebGL? So it's everywhere. Basically it's supported on all major browsers now, on mobile devices mostly. And there's a lot of the web infrastructure that you get to exploit when using WebGL. Like if you're using making a desktop OpenGL application, you have to deal with like, okay, how do I get a window in this on this OS and the whole thing, and you have to kind of redo it for each OS you want to support. Here you just you use HTML, CSS, standard UI, and it's interacting through JavaScript with your 3D scene. It's very easy to integrate into client websites, like I said. You have web services you can tap into. And generally, like compared to creating a native app, distribution is pretty easy. You just update the page on your servers. All your users have access to the latest code, which is a very different situation from, for example, we have an iOS app. And making sure and knowing kind of what version your users are using and all that can be a bit of a headache. So basically, in a nutshell, using WebGL, you get to leverage all this infrastructure that's been built into the web up until now. You get to use that in what can now be 3D applications. So what are the cons? The cons basically comes down to you're taking a high performance application and putting it into this context where people have certain expectations about how websites are supposed to work. It should load immediately, it should be pretty intuitive to use. and it should just essentially work. You know, I mean, people don't, you know, if somebody's installing like a big video game on their computer, they kind of have an expectation that they'll wait a bit. With a website, it's not there quick. People will tend to just move on. Another one is JavaScript. I mean, I love working with JavaScript, but for these high performance apps, there are certain things that are very difficult to do. So like memory management is difficult in JavaScript. There are a lot of like common JavaScript patterns that tend to be very bad for performance, especially when you're dealing with an animation loop, 60 frames per second. If you have any memory leaks in your app, they tend to get very, you know, highly exacerbated in that context. So I'm going to go through like a few of the key parts of the company or key parts of the platform and just talk about like some of the challenges that we face in each part. So the three key components I've discussed. So there's the content, like the 3D models that are in our platform. There's the rendering engine that's built on top of WebGL. And then there's this API and integrating it into client websites. So the content, hopefully this will load nice and quick. I'm going to go over kind of three types. Like we have basically what you could call kind of static content. Like it doesn't move around much. We have things labeled. You can look at the different parts, get names. Yeah, essentially that. Then we have our more, kind of like we saw before, but animated scenes. So this one in particular, it's glucose action on the cell and how it affects, insulin action on the cell. It hits the receptors and glucose starts entering the cell. And then we have what we call tours, where it's kind of animation strung together. Like storytelling is a big part of what we're trying to do. So this one, for example, is like ACL injury and repair. So ACL is this tendon over here. And then as the user kind of walks through, they see the injury happen. And then the repair. So those are the kind of high level types of content we're dealing with. So content, the biggest challenge is size. Like when you're dealing with the web, stuff has to be downloaded. So you want to keep the size down. You have it move quickly. But that's kind of balanced against the fact, and especially like we have a team of 3D artists on our staff. And they, of course, like, and we kind of do too, but like everybody wants it to look good. You know what I mean? You want to have highly detailed textures, really detailed geometry. But that means it's going to take forever to download. If somebody's downloading it on a mobile device, it's going to crash. So there's this, there's always this tension between the detail you want to get in versus how performant and stable the application is going to be. So rendering, a big part of our rendering is really about the interactive side, because we have this complex data that we want to share with our users. And so it's how do we get them, allow them to navigate and draw meaning out of the models that they're seeing. So some aspects of our data that make it kind of more challenging to deal with than like your average just put up a 3D scene is, an anatomical information tends to be deeply nested. You have things inside each other, the brain inside the skull, veins inside the muscle, whatever. So how do you get allow people to dig into things? It's hierarchical. That happens with a lot of information or a lot of types of 3D data, but where, if the user clicks on something, is it the arm, is it the hand or the arm or a finger? Knowing how to allow people to deal with different levels of detail, basically. And then there's the scale. In terms of just normalizing our content, we saw that there's like, the whole human body down to individual cells. How to put that together meaningfully can be challenging as well. So a big focus for us is, giving people different ways to interact with the content. So these are some of the actions or interactions people can have with our content. There's just highlighting, which I showed. I'll show you in a bit, like dissecting. Actually, I might get that, or I don't know if I can do that right now. But so dissecting, so removing objects from the scene, isolating a particular object in the scene, using transparency, using annotations to, and we saw a lot of that in that tour of the ACL, like using the different ways of rendering the objects to make the scene more meaningful. So hopefully this is one of our bigger models. I hope it'll load reasonably quickly. There we go. Okay, so this is our heart model. So yeah, so there's, hovering over, can highlight, which I showed you. The dissection tool. I should get rid of this guy. The dissection tool allows you to like remove parts of the heart. If I want to make things transparent, then I can kind of highlight parts I'm interested in. So it's giving these different ways of letting people visualize the 3D data that they're interested in. So big challenge, and the biggest one we're dealing with since we recently got our WebGL engine working reasonably well on mobile is that, I mean, any website has a challenge on mobile, but when you're dealing with these heavy-duty application, there are extra challenges involved with the limited memory you have, the limited GPU capabilities, and there's the range of devices you're dealing with that it's hard to know when the web page starts up, like, okay, am I on a powerful machine on desktop or on mobile? And there's some things that you can find out about the environment. You can query, okay, like, what kind of WebGL context am I in? How many, of a certain kind of GL variable? I won't get into the details, the precision, what GPU extensions I have available. But another like key ones, like knowing how much GPU memory you have available, isn't directly accessible in your JavaScript context. So you have to kind of develop heuristics and figure out how to navigate those differences. And here, I won't go into the details, but this is one of the biggest headaches I dealt with. So a guy went and just studied, this is different aspects of the GPU capabilities that iOS exposes to WebGL. And here he's just showing that on the iPad, a native application will have access to, basically, like in a nutshell, what it's doing is making the GPU look much weaker to WebGL than it does to a native application. I don't know why they do that. I have my own kind of conspiracy theories, but it's a huge pain. And it's, for those of you that know graphics programming, like this thing in red is it's an extremely limited GPU. And now finally, I'll get into like our embedding, like the integration part of our platform. So basically what people can do is they create a little iframe that embeds some of our 3D content in their page. Some of the basic interactions that you saw, like mouse, dissect, whatever, are built in. And you can customize some of the UI through URL parameters. So that's kind of the basic step. And then we have a JavaScript API to allow really customized interaction, where you can have kind of where the user's clicking around your page and they're updating the scene. So I'll show a quick example of that. So this is a page we did for about.com. They have a page on diabetes. And do I scroll like this? Good. And basically what happens is as you're scrolling through the text, it updates the 3D scene to show you kind of what the text is talking about. And this is like a full interactive 3D scene. And so that was just a nice thing where you really feel, because for me personally, I really love this as an example of our technology, because a lot of the WebGL, if you guys have seen WebGL on the web, it tends to be just kind of in this little box on the side. Whereas this, I really felt like, it feels like part of the page. Like it really is integrated into the site. So API challenges in terms of helping our users, like our more developer, our technical users, like use our API. A big challenge is just in terms of information and education. That in order to use our API properly, it helps to be comfortable with a bit of 3D graphics, the terminology, the concepts, algorithms, how to navigate a 3D scene, what are the concepts involved in that, and then there's the anatomy part, and then just the way we've organized. So there's like these layers of knowledge that we have to kind of ramp our users up to so they can use our platform effectively. And so And for that is just lots of documentation and support. And yeah, so if you guys are interested in trying out our API, this is the website, developer.biodigital.com. I don't know if there are any students here. We do have a summer internship program, if you guys are interested. And that's it. Thank you very much. And I have cards here, if anybody's interested in staying in touch. So, questions? Yes?
Any challenges in creating the models? Well, I guess specifically for WebGL, but
it's just optimizing. Like really, that's and this is something actually like Evan and I work on a lot. Is part of it too is just giving the modelers the information they need to optimize, to know like, okay, your textures are getting too big for this context. But it's really how to have as much detail as possible while keeping the models as small as you can.
And I have another question. Do you have any techniques for progressively enhancing the model based on the capabilities of the device?
So that's something we're working a lot on now, is detecting, based on screen size or something like that, and like using smaller textures since you don't need necessarily as much detail, and kind of loading kind of level of detail, it's called, like where you progressively load more detailed meshes, say, is something we're sort of researching right now. So we'll see. Maybe next year I'll have a more interesting answer. Yeah, in the back here.
I have a question, because they have cross-browser compatibility issues.
Right.
How do you deal with that, especially with WebGL and also with GPUs like AMD and NVIDIA? Like, how do you have to deal with compatibility?
So it's a headache, is the easy answer. Right now, support is not too bad. Like for at least if you're dealing with like the most modern browsers of each for each vendor, their support is pretty good. And the Kronos group, who like is the group that runs or handles the WebGL spec, they've done a really good job of making conformance tests available. So you can really try out a browser and know, okay, are they failing certain tests of conformance that they should be passing? And the vendors do use that. So the slightly uglier answer is just, like we do as much as we can to sort of dynamically find out what kind of environment we're in and to adjust things accordingly, which, can get a bit messy sometimes. Yeah.
What tools do your artists use?
Sorry?
And what tools do your
the artists?
use?
Yeah.
And what sort of data structure do they put it in so you're able to process it?
Okay, so that, so Maya is the main one. They also use ZBrush and, is Mudbox? Do we use Mudbox at all? No. Okay.
Like experiment.
Okay, so mainly like Maya and ZBrush. And then Evan actually is the one who takes the Maya models and converts it into sort of the runtime format that we use.
What sort of data structure do you use?
Well, the data structure is really just to get it in a format that where you can just dump it onto the GPU. So, because WebGL, because the most efficient thing for the GPU is just to have flat arrays of your vertices or UVs or normals. So we get it in that format, and then you can just throw it on the GPU as quickly as possible. Yeah.
The artwork is awesome. Are you looking at monetizing with medical textbook companies, something like that?
If you know any, sure. Yeah, I mean, definitely. Like in terms of just like for illustrations or for sort of online stuff.
It seems like you can do a lot with medical education.
Yeah, so definitely like we are like, so we work with a lot of universities like with their med programs, and there's a few publishers I think we have as well, like McGraw-Hill, for like websites they have on anatomy and stuff like that. I think I saw over here, yeah.
Have you guys played with like any of the VR goggles, like the?
Experimentally, yeah. Like nothing production ready, but we have, yeah. We do have like a view where you get the the two different inputs for the two different sides of the book. Here.
Yeah. Are there any features that doctors would express interest in?
Yeah, always. Like too many. A lot of it has to do with the main thing. The biggest thing is like being able to map their data to our models. So in terms of like regionalizing surfaces in the way that they want, And I didn't show really the annotation mechanism. I could show that after, but where it's just like, okay, this spot, like say if I have a patient and okay, they're injured here. So I want to be able to put a marker on the surface at that spot and then maybe show it over time how it progresses. So that's yeah, like mapping data to and from the models I think is like the biggest request we get and like different ways of doing that. Where was there's in the back here?
I've never done any sort of graphics programming. Now I assume obviously since you can sort of zoom in and out of the models that it probably gives you sort of an equation, like so that, you know, but do you guys actually do it in something like a 3D renderer and then the equations come out of that, or do you sit and actually, like how do you exactly go about generating the WebGL code?
So that, so there's two of us. It's mainly, so Lindsay Kay, who's our other 3D engineer, and myself, like work on Scene.js, which is the JavaScript library that actually goes in, and you do have to kind of, yeah, write the equations yourself, like where you say, yeah, where you dump your mesh information on the GPU, and then I say I want it displayed in this way and like this far away, and it's a bunch of linear algebra equations that you have to put together for that. Yeah. Sir. Oh, yeah.
I'm curious if there's what I would call any physics in the model. So when we saw early on the animation running, if that person has a slightly bit of worn cartilage in one of their knees,
right,
or their IT band is tight or something like that, that's going to throw pretty much everything out of kilter a little bit. It seems like a pretty unique environment where you could actually see how that affects the other parts of the body, but I think that's physics versus
right.
straight.
So that is not. Evan's actually, we've been talking, like he's very interested in having more physics in our engine. Right now it is really kind of statically animated.
I think it's very, very hard, but
yeah, and there's a lot of stuff that it would make more efficient. Like right now, if like anything that looks kind of like particles moving around, like it'll be explicitly tweened, like moved to certain spots by our animators, whereas doing something like that, we were just talking about like doing something like that as a physics simulation in terms of how much data you need to download to the client would be much more efficient. So that is, yeah, it's definitely a direction we're looking at. All right, anything else? Cool, all right, thank you.